Hello everyone, this is the solution of irreversible to reversible conversion videos, and here we will discuss about that problem which I have given in that video. So if you have not watched those videos, so I would definitely recommend you to watch them first, then only look this solution. Try to solve that question and then look at the solution. So what was the question? So let me write question here itself. So I have given you one gate having two input and two output, and I asked you to check whether that particular gate is reversible or not. So this is A, this is B, this was function of AB, and we have function of G, A and B. So output was having two pin with different function. So and we were having some condition already given, like f of 0 0 is equal to 1, f of 0 1 equal to 0, f of 1 0 equal to 0, and f of 1 1 equal to 1. So this was some of the conditions which were given for this gate, means these conditions are applicable for this gate. And function of g was given as g of 0 0 as 0, g of 0 1 as 1, g of 1 0 as 1, and g of 1 1 as 1. So first thing we will check is whether this gate is reversible or not. So let's check. So our first condition is satisfied, which is number of input pin equal to output pin, number of output pin. So both are having 2 2. Now our second condition is whether for a distinct output we are getting distinct input, and vice versa, distinct input we are getting distinct output. There should be one to one matching. So let's write a truth table for this, where we have A and B and function of AB and g of AB. So we are having like this. Let's write all the possible input: 0 0 0 1 1 0 and 1 1. Now let's fill them according to what the condition were given. Okay, so here it is f00 is 1, then this is 0, this is 0, this is 1, and this is 0, this is 1, this is 1, this is 1. Do you see what this look like? So function of A and B is looking like we are having exclusive NOR gate, and function of G is looking like it is an OR gate. So, and yeah, this is just means how we can identify function using the truth table. I think I have covered this in the third or fourth video, something like that. You can watch it. So now let's check whether we are getting distinct input, means distinct output for particular distinct input or not. So for 0 0 we are getting 1 0, for 1 1 we are getting 1 1, but in this case we, for 0 1 as output, we are having two input, 0 1 and 1 0. So we can't say that it is a reversible gate because we are not getting distinct output itself. We can't say that 0 1 was the output corresponding to, it can be either be 0 1 or 1 0. it is not distinct, so we can definitely say that this is an this is a irreversible gate. The irreversible gate. Now second thing, how we can convert this irreversible gate to reversible gate, right? So in the last video I have told you that we will be using XORing. Basically we will be XORing it and converting it into reversible gate. So first let's draw the circuit diagram with actual gate, not just function, with actual gate. Since we have recognized those gates, so we can make it, right? So let me choose a different color altogether. This we will use multiple color to understand. So we are having two input A and B, which are connected to our exclusive NOR gate. So it will look like this, and this is our function of A, B. Now we will connect it with C for XORing purpose, and here we have connected it like this. Now it will be equivalent to f of AB and XOR it is C. So here what is happening? A XOR B, right? And here it is happening like this, and now we will take this input A, this input B, and connecting it with our OR gate. This will return G of A B, which is simply A plus B. This is not plus, this is just operation of plus. Now we will attach this to a fourth input D, and it will be having wait a second, it will be having another XOR which will be equivalent to G of AB XOR of D. Okay, and we know that there will be let me color it like this will be a separate output A and B, A and B. So for 4 input A, B, C, D, we are having 1, 2, 3 and 4 output. Now let's write truth table for this. So actually I will not be using the pen for this. Instead I will be using uh, insert seed table, so that since we are having 4 input variables, so it will be a slightly larger and it will take time to write those truth table. So let me just use the insert seed, because if I draw it now, then it will create a completely mess. So let me draw this table. Let's take whatever maximum we can opt for, and here we will select, we have to table is been created that side. So let me just pull this table here. Will it works? Yeah, it is working. Should I zoom it slightly? Yeah, let me zoom it and slightly move it this side. I can zoom it even. Yeah, this is perfect. I hope this is visible to you. This truth table is visible to you. So let me start filling this truth table. But before writing this truth table, we need some extra row because we will be having 16 possible outcome. Already told you that if there are 4 input, then it will be 2 to the power 4. 16 and plus 1 will be like this additional column. So additional row for heading. So let me insert few row below. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think, yeah, I think this should be enough. And let me do center format, some formatting. If we are doing it, let's do it properly, man. It will be bold, it will be centered, align. Yeah, this looks good. Let's color the input portion slightly different. Let's color it as green. Yeah, this will work. Now let's write, this will be A, B, C and D. Now here we will be having function of A and B. Here we will be having function of the A, B. Okay. Now here we will be having our output. So output will be consisting of A, B and this f of A, B, XOR, XOR C, and in the next we will be having G, A, B and it will be XORing with D. Yeah, will it works? Yeah, it will works. So can we just slightly spread this like this and yeah, now it looks good. So can we color slightly different? Let me color it with this color and let's color the output with slightly different color. Like, will it works? Yeah, it should work. Now let's start filling all the possible outcomes. So as I have already told you, there is a direct way of filling it. Like we can start with 0, 0, 1. Means, see, 8 times 0, then 8 times 1, like this. I have told you this method of quickly filling it. So let's apply that method. 3, 4, 5, 6, 7, and 8. Okay, now here it will be 1, 1, 1, 1, 1, 1, 1. I think 1, 2, 3, 4, 5, 6, 7, and 8. One extra row we have created. So let's delete that. Delete row. Okay, now it should be fine. Now let's write 0, 1, 2, 3, 4 and 0, 0, 0, 0, 1, 1, 1, 1. Here we can write 0, 0, 0, 0. Oh, sorry. In the flow, I am writing it like, no, it will not be like this. 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. This is a quick way of writing all the possible outcomes, because if you keep on remembering things, then it will really take a lot of time. Okay, now let's apply f of ab. So since we have already given the notation here, f of 0 0 is 1, 0 1 is 0, and 1 0 is 0, and 1 1 is 1. Let's apply the same. So wherever f of 0 0 is 0 is 1, 1, 1, and 1, right? And here it is 0 0 0 0. Here also it is 0 0 0 0. Here it will be 1 1 1 and 1. Now g of AB, we know that it is an OR operation, and except G00 all other are 1. So just fill that. G of 00 will be 0 0 0 0. Rest all will be 1 1 1 1 and 1. Right? Now let's start filling the output. So first thing will be same, 0 0 0 0 0 0 0 0, 1 1 1 1 1 1 1 1, and here it will be 0 0 0 0, 1 1 1 1, 0 0 0 0, 1 1 1 and 1. So now we will apply function of AB XOR with C. So we know that when we apply function of AB and whenever we XOR with 0, it will give the same functions. But if we will give with XOR 1, then it will just inverse or flip that function. So let's write. So here f of AB is 1 and it is XORing with C, which is 0. So it will be equivalent to 1. And here it will be z of AB. Z of AB is 0 and it is XORing with D. So it will be 0. So can we start filling it quickly, like XORing quickly like that, 0 1 0 1, like quickly XORing it like that. We know that if it is different, then it will be 1. If it is same, then it will be 0. So we can quickly fill it. 1 1, and for now just means we are XORing f of AB with C. So we will do it quickly, like it will be 0 0 0 0, and it will be 1 1, then 0, then 0, then 1 1 1. It will be also 1. Sorry for the noise, I think background noise is there. I will try to optimize it. 1 1 is 0, and this will also be 0. So this is filled. Now let's do with D and G of AB. 0 0 is 0, 1 0 is 1. This will be 0, this will be 1, this will be 1, this will be 0, this will be 1, then 0, then 1, then 0. Okay, and then it will be 1, then 0, then 1, then 0, then it is 1, then it is 0. So can we see, means now let's check whether we are getting distinct input and distinct output or not. So there is a quick way, of checking whether our output is distinct. Let's see, and our input is distinct or not. So what we can do, we can simply sum this. So this is equivalent to, let me sum those all. So I should insert, yeah, so this is sum. Okay, so this is coming as 8, and what is this? 1 2 3 4 5 6 7 and 8. This is also 1 2 3 4 5 6 7 8. This is 1 2 3 4 5 6 7 8. These are all 8. This should be equivalent to this. So 1 2 3 4 5 6 7 8. This is also 8, and here let's see, 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. So if all are same, this input is equal to output, then it is a reversible. Now this particular gate has become reversible. So this truth table I was expecting from you, you can check with your truth table and see whether your one is correct or not. You can also practice some question from the Google. Just write making irreversible to reversible gates question, and you will get few questions on that. So I hope these solutions help you. uh, you can slightly slow down here for understanding, but it is just simple XOR operation I am performing, so you will understand this. So this is all about how we are making an irreversible gate to reversible. But before that, we have to check whether that gate is really irreversible or not. Okay, so I think this is all. I will meet you in the next video where we will be discussing about error, detection of error, why error happens, and then we will solve how we can resolve those error by adding additional bit to it, like that we will be studying. So this is error correction, and error detection is something which is very important. So I think it will take, means I will take slight time on that, and at least two videos will be required for that. So I will meet you in next video. If you like this video and if you are following this channel, then well and good. And if you are new to this channel, then don't forget to subscribe if you want notification, because one thing is happening that I am not getting much time to put videos every day, not punctual anymore like that. So whenever I put video, you will be getting notifications. So that's what I want. I am trying to finish this playlist as soon as possible so that you can watch it in one go. So either you can wait for few days and watch it together, or watch one by one, that also good, and practice code in miss practice question in between. So I hope you to see in next video. Thank you, bye.